Thanks very much, Lou, and thanks also to you hardy few who've managed to stay here for the final event. Hopefully I don't fumble a baton. So most of us who are involved in looking after young children, SNOT is an intimately familiar part of our daily lives. So we developed SNOTWATCH as a platform to try and understand the impact of common viruses on a variety of child health outcomes. And so what I'll try and do is take you through how we develop this and how it's helping us understand some aspects of the interaction between childhood viruses and uncommon and common health outcomes. So even before COVID pandemic, there were 17 billion respiratory viral infections each year globally. Interestingly, the frequency appears to be higher in high-income countries than it is in low-income countries, but nevertheless, the median works out to about 17 billion per annum. For those of you unfortunate enough to remember Donald Rumsfeld, the former US Secretary for Defense, he wasn't known for his commitment to public health in any way, shape or form. However, he was known, and we're grateful for him popularising the concept of known unknowns, unknown unknowns, and known unknowns. And that actually translates pretty well to public health in many ways. So in terms of common respiratory viruses, we know that they cause runny noses, sore throat, and we know that they contribute to things like bronchiolitis and pneumonia. On the other hand, the known unknowns are, we have an idea that they probably contribute to other health outcomes like febrile seizures, but we have no idea which viruses and how much. As an example, we discovered after we introduced rotavirus vaccine in 2007 that febrile seizures reduced by 20%, not only in Australia by work done by Stephen Lambert, but also in the US by a similar amount. So health outcome presentations, we traditionally get our information about viruses from small hospital cohort studies, and that's really just the pointy end of the data where the most severe presentations occur. And what we miss out potentially in most of our data systems is the milder end of the spectrum. Those that present to emergency departments, we get reasonable information. Those that present to primary care, we often get good clinical information, although it's scattered amongst the data systems, but we tend not to get the microbiological information. And then obviously those that are self-treated at home by the parents, typically we get very little information. And there are data systems now that we can access for most of those presentations. So what is SNOTWATCH? SNOTWATCH, we take de-identified exposures from every data system we can find in terms of pathology for the viral respiratory virus systems, as well as environmental exposures over a given region and time period. We match those to health outcome data from health outcome data sets that cover the same time period and geographical space, but they're not linked in any other way except in time and in space. So it's a spatio-temporal data set, and these slides keep wanting to change on me. So essentially, SNOTWATCH is an ecological spatio-temporal data platform that provides indirect association between exposures and outcomes. And we've developed a statistical model that allows us to derive associations between the two. In terms of exposures, you're all familiar with the multiplex respiratory PCRs that are used in a variety of forms in most of our public and private pathology systems. In terms of other exposures, apart from respiratory viruses, we can also capture gastrointestinal viruses, but also environmental exposures as well, including pollen, humidity, other meteorological phenomena, as well as other cultural things like, for example, school term dates. And then in terms of the outcomes we can capture, so we're a Victorian-based platform, so we can capture both electronic health record and the Victorian Victorian Admitted Episodes Dataset, or VAED, for admissions, VEMD, the Emergency Minimum Dataset, as well as a more real-time dataset called SynServe. In primary care datasets, we've got access to the POLAR and the University of Melbourne Patron dataset. And then in terms of telephone health advice, we can access both Health Direct And then SynServe also accesses the Victorian instance of Nurse on Call as well. And then finally, for those healthcare outcomes that we don't capture in any healthcare data set, we can access surrogate data sets like school absenteeism and childcare absenteeism, because essentially small children are nothing other, mathematically speaking, than virus transfer units. So what have we done so far? So most of our work in SNOTWATCH so far has been looking for associations between viruses and other healthcare outcomes. So our first work was in association with febrile seizures and viruses, and we were able to identify an association between influenza, RSV, and to a lesser extent, human metapneumoviruses as being associated spatially and spatiotemporally with febrile seizures. Chilblains, we were able to associate with COVID toes, as many of you will remember, especially at the start, as well as obviously the natural association with colder temperature. Interestingly, that association was strongest in children compared with adults, although it was a very clear association in adults as well. We've been able to associate a variety of viruses and then, not surprisingly, the environmental exposures with school-age asthma, age 6 to 19. And then I'll talk in more detail about the last two, which is paediatric hepatitis clusters and then Kawasaki disease, which is a rare paediatric but serious paediatric outcome. And I'll talk about that first. So essentially what we took is respiratory viral data, Kawasaki disease, and then looked at association between viruses and instances or admissions with Kawasaki disease. So for those of you who are not familiar with Kawasaki disease, it's an uncommon acute inflammatory episode of unknown cause that classically presents with fever, a rash, red eyes, red mouth, and swollen periphery. We don't know what the cause is. There's no diagnostic test. We recognise it syndromically. But what we do know is that the most important outcome, which is aneurysms of the coronary arteries, improves if you diagnose it early, and you reduce that risk by giving IVIG. The reason we looked at it is that it's long been purported that an infective trigger is likely. There has been some suggestion of seasonality. And during COVID, there was a similar but slightly different manifestation called PIMS-TS or MIS-C that also reared during COVID, especially during the earlier strains with COVID, far less with the more recent strains. We looked at Victorian data for a 10-year period between 2011 and 2021. So essentially what we had is just over 1,000 cases of Kawasaki disease and just over 153,000 positive PCR tests over that time period, largely from the two major tertiary hospitals at this point of the study, which was Monash Health and the Children's Hospital, noting that these were all respiratory viral samples. So whether they're in adults from Monash Health or in children from Monash Health, we took those because we were looking at exposure rather than looking at episodes within children itself. So we initially did data visualization and mapping and then used a negative binomial regression analysis to look at the spatiotemporal association between viruses and Kawasaki disease outcome. We also had a natural experiment during this time because we had all of the public health interventions that drastically changed the epidemiology of common respiratory viruses during the COVID period, which gave us an additional insight into impacts. So these are the Kawasaki disease presentations by month of year, average by month of year, pre and during COVID. And as you can see, there were some months where there was a major difference during the COVID time compared to the non-COVID time, suggestive that maybe circulating viruses might have something to deal with it. I'm sure you'll all be able to derive all of the associations here because it's such a clean graph. But essentially, first we visually mapped out in blue the episodes of Kawasaki disease and in the squiggly lines from all the different viruses. And that's all you need to take from this graph. When we looked at the specific associations, noting that this is an analysis where we did multiple statistical comparisons. So we took as significant anything below 0.01 in terms of the P level. And the only viruses that stood out were human metapneumovirus and RSV. Interestingly, during COVID, first of all, no association with COVID whatsoever. But secondly, RSV came close to an association but didn't meet our criteria for significance during COVID, which was also reflected by far less RSV occurring during those COVID times. So interpreting the findings, first of all, there was no seasonality identified in our Kawasaki disease conditions. There were changes to Kawasaki patterns pre and during the pandemic. We noted some viral associations with human metapneumovirus and RSV, and SARS-CoV-2 was not implicated at all. The advantages were this is a relatively large cohort. We were able to get additional granularity by using a spatiotemporal analysis rather than the traditional temporal analysis, and we were able to gain benefit from the pre and during pandemic years. On the other hand, ecologic studies can largely talk about association rather than causation, and we really need hypothesis testing studies to back this up as well. And there was initially skewed viral PCR coverage. The good news is that since we've done this study, we've gone from about 200,000 tests available to over 4 million tests available. So we now have a broad geographical representation across Victoria to do these studies again. Whoops. Next study, very briefly, I'll talk about. Some of you may remember a couple of years ago in Europe, there was an outbreak of clusters of very severe paediatric hepatitis. In some of those cohort studies, an adenovirus 41, type 41, was associated, not a respiratory adenovirus, it's an enteric adenovirus, but we looked to see, did we have any paediatric clusters that we'd missed previously, and we certainly found some. This is a SAT scan analysis looking at geographical clustering of episodes of paediatric hepatitis. And then when we looked in terms of the viruses, pre-COVID, pretty much every virus was associated with clusters of hepatitis, except for respiratory adenoviruses, interestingly. And then during COVID, only 2 viruses stood out, a coronavirus, which, as you know, is a combination of both rhinovirus and enteroviruses, so we've missed any seasonality advantage there, and RSV. So in summary, SNOTWATCH gives us a platform to answer a bunch of questions around associations between viruses and health outcomes. We can also look at other environmental exposures. We've got access to a whole variety of data systems because we don't need identifiable data. That gives us increased access to a large amount of data. We can associate exposures and outcomes. We're refining the statistical model to begin to attribute a proportion of burden for each of those viruses, which then means we can extrapolate economic impact as well as health impact. And we're just looking at invasive group A strep as well at the moment. So finally, I'd just like to thank all of the team that's been working on, in particular, Rana Sawiras, her PhD contributed most of the analyses you've seen, and Toon Nguyen, who's developing this further, and Aaron Wyman, who's really the backbone of this program. Thanks very much.
Thanks. And I've got an interest in air quality, air pollution, particularly traffic pollution, which is an issue in Melbourne. And is that included in SNOTWATCH?
Yeah, we've got access to some air pollution markers. Typically the problem is that there's relatively few sampling points, so we don't get the geographical granularity for analysis as we would like, but we can still do it just with a larger clustering.
Thank you. Tony.
Jim, there was an out-of-season RSV outbreak after COVID documented in both Sydney and Melbourne, which essentially was uniclonal. Did you see any evidence of that giving you a spike of Kawasaki?
I think we could now. On these analyses, we didn't really have that timing to capture that properly, and we also didn't have the volume of data we do now. Yeah. So I think we will be able to look at it in new analyses, but we didn't capture it in these.
It's fascinating if you've got nothing and then boom. Yeah.
Kanta?
Can you use this to look at things like myocarditis and pericarditis and tie it in with whether some of it happens with infection and not just vaccination?
Yes, so we haven't done so, but the model exists. Before, especially given that most of the data occurred before everyone moved to rat tests, and we lost the ability to get that frequency of granularity. But yeah, we do have access to Trevi, which gives us all of the statewide testing.
This is more a comment than a question. It'd be really good to touch base after this event with our primary sense data with the 11 million unique identifiers. We did the asthma comparison and the usage of steroid inhalers in general practice and overlaid it with the severe thunderstorm event data. And we're able to see a really close correlation. So yeah, really interesting.
I'd love to. We've done some work with polar, interestingly, initially with asthma. So I'd be very interested.